Let's say you're at the store and you go to buy something. And you have to give the money to the cashier. So you hand them $5. If we were to describe the amount of money that was transferred, we would say that you lost $5 and the cashier gained $5. Well, what do you notice about these values? Well, the cashier gained the exact same amount of money that you lost. Well, what does this have to do with heat? Well, let's say we have two objects. We have a hot object and we'll have a cold object, and we'll put them next to each other. We described before that heat gets transferred from high temperature to low temperature. So we'll show that the heat's going to go from the hot object to the cold object, meaning that we lose heat from the hot object, and the cold object gains heat, negative Q and positive Q. The money example works the same way for the temperature heat example, in that the Q lost must equal negative of the Q gained. If the hot block lost 10 joules, then the cold block must gain 10 joules. The reason why there's a negative sign here is if I go to plug these values in, if I say we lost 10 joules, well, negative 10 is not equal to 10 gain, because this is positive, so we have to throw a negative sign in there to make the numbers equal. But the amount of energy lost by one object equals the amount of energy gained by another. The amount of energy lost by one object must be equal to the energy gained by another object. And the reason for this is the law of conservation of energy. So the law of conservation of energy says we can't lose or gain energy, we can't create or destroy energy, it just gets transferred from one thing to another, one form to another. So the total amount of energy lost by one object must equal the total energy gained by another. And this is a really important concept when we want to start determining the specific heats and identifying unknown objects.